we were, as I mentioned the other day, there were a couple of applications, particularly about trigonometry, we're going to take into what we might call real-world scenarios. One was the angle of elevation and depression. We did that on Friday. Today we're talking about variance and thinking about the way that we can use trigonometry to help us do some locating of ourselves on maps or on the Earth and that kind of stuff. So there are two ways that we will describe directions using our bearings. There are two ways. First is using a north or a south with an angle, and then an east or a west. Okay, so that I'm going to call those the north or south bearings. Okay, that's one type, and the other one is the 3-digit bearing. They're the two types of ways we're going to use to describe a direction. Okay, that's what a bearing is, the direction that you're taking. So when you're starting from somewhere and you're heading a certain direction, how do you know what direction that is? Okay? Let's run through each of those two really quickly. So the first one is where we start from either north or south and then turn from that direction a certain number of degrees, and that's the new direction we're going to face. Okay? So depending on where we want to go, let's say we're going to be heading in this direction down here. Okay? And so we would call that one, we would call this direction here, starting from south, 50 degrees east. Okay? So remember that that's north, east, south and west. That direction there, we start south, 50 degrees east. And so we would call that N 50 degrees E. N? I meant south, sorry. South, 50 degrees east. Okay, the north or south bearings has us starting from either north or south and turning in a certain direction, east or west. Okay? Now that number there, because we're going to start from south and go anywhere in this kind of way like this, or from north and go anywhere down here or anywhere down there, that number there can't be more than 90 degrees. Okay, if we want to say north 130 east, well that's what that would be, but we don't say that, we say south 50 degrees east. Okay, we use the number that's less than 90. Okay, we either start from north or south, whichever one is closest to the direction we're going to face in, and call it south a number and then east or west. North a number, east or west. Okay? That's just one way of describing bearings. Any questions about that one? Are we good with that? Nice and easy? Yes? Yeah. Let's see some nodding over here. Alright, a 3-digit one, as it sounds like, is a 3-digit number. Again, we're starting from north, this one, but this time only north, not south. So we're starting from north, and we turn in a clockwise direction. That's over here. We're going in a clockwise direction. And so we're starting from here facing this way, and we turn and we go all the way down to this one. We would call this one a bearing of 130 degrees. That's all we would say. If we're talking a 3-digit bearing, it's just the numbers. You don't need to say north, south, east, or west, or that kind of stuff. We just call it the numbers. Okay? Always starting from north, always going clockwise. How do I get 130 by the way? How do I figure that out?
90.
So that's 90 there, and if that's 50, that must be 40, so 90 plus 40 is 130. Could have also said, well that's 180 around to here, but I'm 50 less of that, so 180 minus 50 is 130. Think of it that way too. Okay, if we're going to go to this direction up here, so that's 60 degrees there. Okay, so again, we're starting from here. Which way are we going? Right, clockwise, and that's only 30 degrees there. I would call that one 0, 3, 0 degrees. You need to put the 0 at the front. Okay, it's 3 digits, always must have 3 digits. And so it doesn't matter whether it's a 30 or it couldn't be like 2 degrees. 0, 0, 2 degrees would be the bearing. So you must have 3 digits in those bearings. Okay, again, the biggest number you get to is 359.999 whatever. Once you get to 360, you wouldn't say 360, you just say 0 degrees. Okay, any questions about bearings?